So we're asked to find the area under the curve y equals 1 over x squared from x equals 1 to t. And we're going to do this 3 separate times. 1 for t equals 10, 1 for t equals 100, and then 1 for all values of t greater than or equal to 1. So under the entire curve. So if we're doing from 1 to 10, basically what we're looking at is the definite integral from 1 to 10 of 1 over x squared dx. Or we may want to rewrite this from 1 to 10 of x to the negative 2 dx. And now we just have a nice definite integral. So we take our antiderivative. This becomes, we increase the power by 1, divide by our new exponent from 1 to 10. And let's go ahead and rewrite that as negative 1 over x from 1 to 10. Nice thing is this is going to be the same antiderivative we use in the other problem, so we won't even have to recalculate that. Now we plug in our limits, and it's going to be negative 1 over 10 minus a negative 1 over 1, which is negative 1/10 plus 1, or 9/10. So there it is from 1 to 10. The next one we're going to do is from 1 to 100 of 1 over x squared dx. We already know the antiderivative is negative 1 over x, so I'm going to skip that step because we did it in the last part. From 1 to 100. So that means we have negative 1 over 100 minus negative 1 over 1. So we have negative 1 over 100 plus 1, which actually gives us 99 over 100. You're probably, even with just 2 examples, already starting to see a pattern forming and probably can identify where the next one's going to go. But let's go ahead and do this, because we'd be looking now at an improper integral from 1 to infinity of 1 over x squared dx. So before we do any antiderivatives, we have to rewrite this as a limit. So limit as b approaches infinity of the integral from 1 to b of 1 over x squared dx. Now once again, we do already know the antiderivative, so that's going to save us a little bit of time. But we do have to write the limit as b goes to infinity and make sure our lines are equal. And we have negative 1 over x from 1 to infinity. Excuse me, not 1 to infinity, 1 to b. b is going to go to infinity. So we have the limit as b goes to infinity of negative 1 over b minus negative 1 over 1, which looks really familiar from all our other answers. And we now have something we can take the limit of, because as b goes to infinity, this part right here is going to go to 0. So we end up with 0 minus a negative 1, or 1, for the total area under that curve from 1 to infinity.